By the turn of the century, human exploration beyond Earth orbit completely stalled. The momentum of Apollo decayed into rust and static museum exhibits. In 2001, NASA had no concrete timelines for sending humans to Mars. There were no serious colony proposals on the table. The conversation about reaching the red planet was limited to vague promises of someday. The global aerospace industry operated on a rigid, highly outsourced business model. Giant defense contractors built enormous, bespoke rockets using single-use hardware. Every component carried a premium, and after a single launch, millions of dollars of machinery were dumped into the ocean. Reaching Mars was a logistical impossibility under these economic conditions. Escaping Earth's gravity required a total departure from how rockets were built and financed. Flying home from a failed attempt to buy refurbished Russian missiles, Elon Musk opened a spreadsheet to calculate the raw material costs of a rocket. He realized the industry was expensive because it was designed to be, not because the physics demanded it. He pivoted to vertical integration, building components in-house. His new company, SpaceX, would use off-the-shelf commercial electronics and treat hardware like software, iterating constantly and accepting failure as a source of telemetry. That theory was tested on Omelek Island, an isolated speck in the Pacific. The team worked through tropical isolation and 3 consecutive explosions of the Falcon 1 rocket, which depleted nearly all of the company's original capital. By the fall of 2008, SpaceX and Tesla were bleeding cash and approaching total bankruptcy. The 4th Falcon 1 stood on the pad, representing their absolute last chance. That 4th rocket achieved orbit. Shortly after, NASA awarded SpaceX a $1.6 billion contract to fly cargo to the International Space Station, a cash infusion that pulled the enterprise back from the edge of collapse by Christmas Eve. Falcon 1 proved that rapid iteration could produce a working orbital rocket on a budget. However, hauling small payloads into low Earth orbit was only a fraction of the infrastructure needed to transport settlers across the solar system. Imagine booking a flight, and after landing, the airline throws the 747 into a scrap heap. That was rocketry's standard procedure. SpaceX solved this by propulsively landing the first stage. As boosters began touching down, launch costs dropped severely. Steering a 14-story metal cylinder through the atmosphere and sticking a soft landing on an autonomous barge in the Atlantic Ocean went from an experiment to a routine weekly event. By offering discounts on flight-proven boosters, SpaceX captured the majority of the global commercial launch market. They adapted the system to fly crewed missions, returning astronauts to space from American soil for the first time since the shuttle retired in 2011. Falcon 9 demonstrated that reusability could dominate the launch market, but moving millions of tons of cargo millions of miles across the vacuum required a significantly larger financial and physical engine. While the rockets grabbed the headlines, a secondary project called Starlink began deploying thousands of small satellites into low Earth orbit to provide high-speed broadband to remote areas. Telecom subscription services scaled differently than government space contracts. By 2025, SpaceX reported $18.7 billion in revenue. This predictable, recurring cash flow provided the capital to bankroll deep space hardware without relying on NASA's budget alone. That hardware is Starship. Standing 400 feet tall, it is a fully reusable, super-heavy launch system designed to carry upwards of 100 people and over 150 metric tons of cargo per flight. Developing it required reverting to the process of learning by exploding. From 2019 onward, prototypes routinely blew up on the Texas test stands. The engineering team absorbed the data from every debris field, rapidly upgrading engines and propellant tanks, until the V3 variant successfully executed its orbital flight tests. Starlink's recurring monthly revenue directly pays for those iterations. The company tied an infinite capital loop to a high-capacity transport system. Building a colony on Mars requires more than just transport. It requires autonomous life support and hardware that can withstand years of deep space radiation. To solve the intelligence and hardware gaps, SpaceX acquired the AI company xAI and announced Terafab, a specialized semiconductor facility. These acquisitions created a specialized supply chain. Starship handles the logistics of the heavy lift, and Starlink provides the communication backbone. Terafab builds the radiation-hardened chips, and xAI writes the autonomous software needed to manage off-world systems. In June 2026, SpaceX took this ecosystem public, setting market records with a valuation of roughly $1.75 trillion based on its massive asset base. Through equity structuring, Elon Musk retained about 42.